Why do batteries fail? Well, vehicle batteries can fail for several reasons. A battery has a serviceable life, and like most things, this lifespan can vary depending on a number of things. Whilst a lead-acid battery is in use, it sheds tiny amounts of active material from the surface of the plates. Over a long period, this degradation results in less surface area on the plates and therefore reduces the battery's capacity and amount of current it can deliver. If a battery is subjected to deep discharging in excess of 35% and rapid recharging, large amounts of active material is lost permanently from the plates, resulting in premature aging. This will get to a point where however much you charge the battery, it will never recover enough to be serviceable. There are two types of sulfation: reversible or soft sulfation, and permanent or hard crystallized sulfation. Sulfation is a normal part of the operation of a battery and occurs every time a battery is discharged. Acidity of the electrolyte solution decreases and lead sulfate deposits on the battery's plates from 12.4 volts and below. If the battery is quickly recharged, the soft lead sulfate is displaced from the plates back into the electrolyte and the battery will perform normally. If left in a discharged state below 12.4 volts, lead sulfate converts to a stable crystal on the plates. The hardened lead sulfate acts as an insulator, reducing the available surface area and therefore reduces the battery performance. For a vehicle that is hardly used and/or only used for short journeys, it is highly likely that the battery is suffering from sulfation and will, at a point, suffer from irreversible damage that shortens its life. Excessive hard sulfation can even damage and distort a battery's casing. Acid stratification. This is when the acid in the electrolyte solution concentrates at the bottom of the battery, which results in low acid strength in the upper cell area. This can sometimes be identified by a higher than normal voltage reading, but the battery is unable to deliver sufficient current to start the vehicle. Acid stratification is more common in the cold winter months as the cold temperatures increase the internal resistance of the battery and therefore the time required for it to become fully charged. Short distance driving while using a lot of electrical consumers increases the effect of acid stratification as short distance journeys are insufficient to heat the large internal mass of the battery and reduce internal resistance. Acid stratification therefore occurs if the battery is kept at a state of charge, SOC, below 80% and never receives a full charge. The consequences of acid stratification are that the higher concentration of sulfuric acid in the lower part of the battery means faster plate surface erosion in the lower plate area and limited performance of the upper area. If a vehicle's charging circuit has gone faulty, this can shorten the life of a battery and can cause it to fail prematurely. This could be an over- or undercharging problem. Undercharging can lead to failing to start and sulfation, and overcharging can overheat, boil, dry, and heavily damage the battery plates. There's also a risk of explosion. If an incorrect battery is fitted to a vehicle, it could fail prematurely. An undersized battery fitted to a vehicle could suffer from excessive draw, causing excessive heat and premature active material loss. It could also be receiving an excessive charge rate, causing premature plate damage. In a situation where an oversized battery was fitted, it would more than likely never receive a full charge, and would therefore suffer from acid stratification and sulfation. Not only can a battery fail due to these reasons, but even before a battery is sold, it can fail. A fully charged battery is approximately 12.7 volts, and if kept as near to this voltage as possible, the battery's life would last as expected. Internal breaks can be identified if a battery has no voltage reading. A single cell failure will make the battery fail completely. Casing damage can cause the electrolyte to leak. Many modern batteries are maintenance-free and have sealed tops. However, there are still many batteries that do have removable caps and should be maintained. A high number of these batteries fail due to insufficient electrolyte. Once the fluid drops below the plates in the battery, the active area is reduced, output of the battery will drop, and the exposed plates can suffer from premature damage.